This is 1.6, day 1, part 2. We've covered vertical, horizontals, and reflection transformations. We're moving on to our last two, vertical stretches and compressions, and horizontal stretches and compressions. These are the ones that are probably the hardest to get because you have to now physically change the shape of the graph. When you talk vertical, that is going to be in front of the function, a multiplier. And there's two scenarios, when you have a number greater than 1 and when you have a decimal or a fraction. And what you do is you are multiplying that y value by that factor. And we're going to do an example of this later on. The last one for you to write down is the horizontal stretches and compressions. These are going to be inside the function now. And we have to do a little change. We have to reciprocate that scale factor. So remember, if something is 1/2, we would reciprocate that to 2/1. And then again, we have numbers greater than 1 and numbers that are fractions. We'll give you a little bit of time to write that up. And then later on in our lesson today, we will show you some examples of this green and this blue one. Okay. These are the parent functions. You already have them in your notes. So let's just quickly review them again so you can see these shapes, and then we'll start going on to another example. So the first one in the red is the parabola. It's a quadratic. There's the parent function. Starts at 0, 0, then it goes over 1, up 1, over 2, up 4, etc. The absolute value we just talked about, that's the shape of the V. The square root we just talked about, that's what I call my half of parabola going off to the right. Then we also talk about in Algebra 2 the cubic, which is what we call the shape as a snake. The step function we talked more specifically yesterday. I just focus on where it starts at the origin at 0, 0, closed circle, going off to open circle. And then it jumps up to 1, 1. Closed circle to open circle. The last two are the reciprocal functions. There is a new one that I'm going to put on here. They don't really talk about it in the book, this red one. So we have the green, which we talked about yesterday, and then this red one. So f of x equals 1 over x, and then f of x equals 1 over x squared. And I can go in more in detail in the next slide with this last red one. So here's the parent function for f of x equals 1 over x squared. Again, we're trying to move away from this, the x, y chart, where you point plot. You're evaluating the function. You're getting out a y value. You're graphing them all out. We're moving away from this and focusing on the transformations, graphing those critical points, and applying the transformations. So here's what the graph would look like. Notice the asymptotes. There's a vertical asymptote, the red one, at x equals 0. Because x cannot be 0, it makes it undefined. Then there's another horizontal asymptote at y equals 0. Okay, first example here. I don't want you to write this problem down. I think it's pretty easy to understand. So this is a function that's been graphed out. It has these little line segments. These are the ordered pairs. If I said, transform this function where it says y equals f of x plus 4, what would you tell me to do? What would we do to this graph, this black graph? We would move it up 4. It's a vertical shift 4 units up. So again, you're not writing this one down. So we would just pick up the entire black graph and move every order pair up 4 units. And I'm going to do that on my slide. So this 0, negative 1 is going to go up 4. And then the next order pair, 1, 0, is going to go up 4. Here's where it will be. And then 3, 1, goes up 4. And then 4, 2. Next example. This is what I would say maybe I would write down, because now it's focusing on a vertical stretch. What it's saying is take this black function, and now what's in front of that function? A 2. It's a multiplier. It's in front of the function. So what we have to do is we have to vertically stretch by a factor of 2. Dot, dot, dot. Take every y value and multiply it by 2. So you could either do it in your head and then make those changes on the graph, or we're going to just write it down on the right-hand side. So if you want to just graphically do it, or in your head, or what we're going to do over here. So I'll give you a little bit of time to write up this graph. All right, so we're going to multiply each of those y values by 2. So negative 1 multiplied by 2 gives us negative 2. Next order pair, 1, 0. Multiply that y value by 2. Still get 0. Next one, multiply 3, 1 by y value of 2. And then the last one, what do you get there? 4, 4. And then we will graph those ordered pairs. So here's over 0, down 2, over 1, up 0, then over 3, up 2, and then over 4, up 4. The shape has now changed. That black function is now being stretched by a factor of 2. Okay, I'm going to stop the video. We'll pick back up.